to hit the. Hello, everyone, and welcome to the NARTS webinar, Evaluation and Seating Interventions for Clients with Supra-pelvic Scoliosis. Our presenters today are Sam, Hannah, and Bart Vanderheyden. Sam is a CEO and owner of Symmetric Designs and has worked as an ATP supplier for over 9 years. He's passionate about complex rehab technology and developing high quality innovation and solutions. And Bart is specializes in the field of seating and mobility for the past 27 years. He studied physical therapy in Ghent, Belgium, and worked with clients with CP in Germany and neurological rehab in the USA. He has a physical therapy practice with his wife in Belgium. So I'm going to turn it over to them. They can talk more about this exciting work that they're doing on mat evaluation for scoliosis.
Okay.
Thank you.
Yeah. I'll just give a brief introduction about Symmetric Designs. So we are a complex rehab manufacturer. We have a full range of head positioning for basic needs to complex needs. From our Apex headrest pads, which are just a plush option for head support, to more complex specialized positioning, such as our Savant, which is a custom moldable gel-filled headrest. And then we have a full range of headrest hardware, including a really unique interface called the Axion, which is actually the only interface that allows a headrest to have lateral rotation. So for those clients that have, very neck muscle weakness, but they still have enough strength to look left to right, you can allow the headrest to move with them and still be fully supported. We also manufacture the Headmaster collar, which is a very low profile, lightweight method of supporting the head from under the chin. And then we also have trunk positioning. So we manufacture freeform seating, which is our custom modular seating system. And Bart will be talking about that a little bit more, but it's coded as custom seating in the United States and in Canada, and we offer it as backrest kits, which is kind of an off-the-shelf solution to providing a client or a patient with a custom moldable backrest that you can continuously change, adapt to growth, to weight fluctuations. And then we also provide freeform seating as full body systems. So we manufacture the full body system here in-house, but we also send kits for ATPs, seating technicians, orthotists to shape and configure a custom molded full body seat and backrest together as one system. So we also have a number of new products coming out later this year with a real focus on microclimate, with a focus on heat and moisture dissipation. So keep an eye out for those. And without further ado, I'll pass it over to Bart, and he can talk about this kind of exciting new approach that we have to doing a mat assessment in combination with creating a full body seating system. So it's kind of a new, really interesting method that we're quite excited about, which should making a custom full body seating system much more efficient and have the ability to adapt and to make changes on the fly. So I'll pass it over to you, Bart.
Thank you, Sam. So also thanks for the introduction, and I think we got to start. So it's very exciting. It's very exciting. Yeah. So we're trying to figure out a better way of fitting full body systems, and I will give you an example as well. So it's quite exciting. So we I worked on this technique for many years, and COVID was a good time. It gave me a little bit of time to work on assessment techniques, and then I talked to some experts in the field, and they suggested to initiate with a face and content validation. So at the end, there will be a link, and it's also important for you to know that we're going to focus today on part 1, which is supra-pelvic scoliosis. There's also infra-pelvic scoliosis, cervical range of motion, which is an assessment technique really important when you're trying to fit head supports. Hamstrings range of motion deficits helps you to also determine what a correct pelvic to thigh angle would be in combination to femur to lower leg angle. We're also going to talk, there's also a part 5, which is an assessment for hypertone clients, dystonic users, predominantly with a strong tone. And then there is also an assessment technique for clients with kyphosis and sliding. But, I have to start somewhere. So we're going to start with supra-pelvic scoliosis, quite exciting. So first of all, what is a supra-pelvic scoliosis? So it's an obliquity that can be the result of a scoliosis, and it's very often between the lumbar spine and the thoracic spine. And if the spine is, of course, oblique, if there is a rotational deficit and a frontal deficit, then of course you will also tend to see asymmetric ranges of hip abduction, hip displacements, or hip extension. And if that becomes a permanent range of motion deficit, you can talk about infrapelvic scoliosis, because the predominant reason for these deformities of the spine comes from the lower range. Of course, it's also possible that you have infra and suprapelvic scoliosis. So if you combine those two techniques, you have then an assessment or a med assessment specifically for those two techniques. So the pelvic obliquity can be the result of scoliosis and range of motion deficits. They are important for a client. They cause pain, often pain. They can also cause pressure injuries because you're loading on one side of the pelvis. Seating stability is an issue, respiration, functional ability. It becomes harder to maintain your upper extremities in a functional position or use them for functional activity. And it also becomes difficult for you to use your head, and deglutation, for instance, can also be a functional ability disturbance. So that's what we're going to talk about. So how to assess them, so before we do anything, we need to understand a little bit what is possible and what is not possible. And typically we use the med assessment. It's a hand-on physical assessment tool. It's a mechanical assessment tool. That's short for med assessment. And it's intended, so that's always very important to know, that it's always intended to inform about the selection of an appropriate seating system. What is the function, the shape, and the size of the system? So your technique should provide you that outcome. And of course, you need to take in the client's goals, individual needs and wishes of the family and the caregivers, and of course the client, functional needs, posture, and pressure injury management. So that's the whole way to do it. And typically, the assessment, the med assessment, is done in the existing seating system. So an observation on how, if the client has already an existing seating system, you're observing how they are doing. And then you're also doing a supine position on the plinth. And then the main goal is there to determine if your deformity is fixed, flexible, or partway flexible to neutral, somewhere in between fixed and flexed. And that's very often the case. And now the question will be, is it fixed, flexed, or somewhere in between? And if it is somewhere in between, how much? Because you need to use that data in order to work with a seating solution or work with an intervention. And then the third part of the med assessment is done in seating on a plinth, and then you simulate PSDs, postural support devices. And that can be anything from holding your hands to support the scoliosis of the client, and then simulate what would work best for the client. And you can use foam wedges or something that simulates the solution that you intended to use. and then you see if that would work for a client. Of course, you're kind of already guessing if you're using foam bits and pieces, they compress when they're being loaded. It's really difficult to get a consistency or use that data to have then an exact prescription or a position in the wheelchair or in the seating system. So that kind of triggered me to look a little bit more in detail on how to do it. Yeah, so and I have an example for you. So this is a user with Duchenne muscle dystrophy, and the user complaint here is that he has a hard time using his right side of his arm. So you can see this, and the right side is very crucial for him because that's his control of his power wheelchair. So we needed to make sure that we find a position where, because that's the user's need, he expressed that to us, where he could work better, or he could function and control his mobility device better. So that was the main question. So you can see how he sits. So your observation, you can pretty much do this also when you are on this picture. You see an obliquity, you see a rotation of the shoulders. So somewhere in between there will be a curve. There's an asymmetric loading. One knee is more in front than the other knee. You look at the lower extremity position, and I blur the head because we have in Europe this GDPR, so data protection of clients. So I want to protect the identity just to make sure that we keep the information confidential. And then, you know, if you have additional data, you can also see, for instance, on an X-ray, that the client had spinal surgery. So it's a rod extending down to the pelvis. So the pelvis will be locking the spine with those rods. So you have like a unit. The spine pelvis is a unit. And you can see it's a long rod, so the entire spine will be fixed, and the pelvis will be fixed too. But if you look at the X-ray, you see clearly a strong obliquity, a rotation, and on this side, unfortunately, there's even a subluxation of the hip. So we have a supra and infra-pelvic scoliosis. We're going to focus on the supra-pelvic scoliosis again because we need to control the topic a little bit. Yeah, but yeah, so the questions that we have as a clinician, as a technician, as somebody who's providing rehab equipment is, before we can do any recommendation, is is it fixed, flexible, or partly flexible to neutral? And of course, here we have a fixation of the pelvis and the spine, so it will definitely be fixed. But the next question is, how do we position the laterals? How do we position the hip guides or the hip supports? How do we position the lateral trunk supports? You know, the lateral trunk support, to be consistent with ISO terminology. If there is a flexibility in the spine, which will probably not be the case for him, so because it's surgically fixed, then I would need to make sure that the degree of mobility is defined, you know, because I need to understand exactly where the placement of those supports will be, of those postural support devices. And then also, how can I build or change a seating system from these findings, from the assessment for? So with that, I mean basically that you need to produce data, and that data must be used in a way so for the purpose of your eval, which is basically a seating intervention. So we need to make sure that the data that we're producing can be used. And then, of course, you also know that if I'm changing, for instance, in this case, if I'm changing the position of the trunk, it will also have an impact on the pelvis, because the trunk and the pelvic are connected here. So then the next question is, when I position the trunk in a certain position so the client can access with the right hand the control system of the wheelchair, what do I specifically need to do with the pelvic support? Do I need a build-up on the left side, the right side, and how much does that build-up need to be? And it would be nice if that data would be provided in distance measurements, because then somebody can build it or can actually construct a solution. So, and then specifically for building, it is important that you are looking at the amount of lateral trunk support that you need. Is it one? Is it two sides? The height of the placement of the lateral trunk support, and that would be nice if you have that in distance measurements as well. The amount of offset, that would also be good, and the amount of buildup under the ITs in case of a pelvic obliquity. So that's what we hope to produce. And so what's next? So I've been thinking hard. So I looked a little bit at different assessment techniques. So there's a lot of data out there. It seems in Europe that there is not a very big consistency. Every institution and every clinic does kind of their own thing, but they all tend to have a similar format. So it's not like it's different, so much different. There seems to be a tendency to document a meta assessment. So I based myself here on several assessment formats, just to give you an idea on how it's used. Agency for Healthcare Research Quality. So I used that as an example. So here again is the case, and in the middle you see the assessment form, and then it says observe the patient. So we call it client, sitting and supine, and complete the observation below. And you can say, well, yeah, I'm doing that. The client seemed to have a pelvic rotation left, pelvic obliquity left. And then you already see something that is difficult, of course, in terms of provision. Is that thoracic kyphosis, or is that scoliosis mild, moderate, or severe? Now, that seems very subjective to me. You probably agree with me. How can I, if I say it's moderate, what can I do with that? So it's not so easy. So the form continues, and I'm looking at the continuous of that form. So then it says, identify the seating problem with the client and underlying reasons. That makes a lot of sense. And if you go more into the physical eval, if the client leans left, right, or forward, reason fixed pelvic obliquity. Yeah, that's probably the case with our client. And then the solution is already kind of pre-filled in. Foam, air, or liquid cushion to fill space between bony prominences and seat surface on low sides. Now, I get it, but how much build up? How much? What are the physical characteristics of that intervention? So what are the specific dimensions and interventions of the PSD? It keeps going. Contour cushion with large well space. Yeah. Not sure if that's going to help our client. And then another thing would be to modification to support both longer and shorter extremities. Yeah, how much? It still is quite vague. And you see now the problem. So somebody is making a solution, somebody's assessing it, and the person that uses the data from the assessment form to build something is kind of stuck because they don't have a lot working, so they don't have a lot of data to work on. So that makes it really hard. And then the next part of the eval is not relevant for supra-pelvic scoliosis, but still all these questions that I raised previously are still open. So we still don't know the exact amounts. So and that started to trigger it, because other data forms do the same thing. It's so in general, you can say that they record body segments and not the interaction between body segments. So in our specific case, if you say, well, it's a moderate or a severe scoliosis and it's fixed, yeah, it would determine that, but it still doesn't tell you what you need to do with the pelvis in order to have a better upper extremity function, which is the need of the client. So there is no interaction of, there's no way to figure that out from the eval form, the impact of the range of motion of the segment on proximal or distal segments. So that makes it really hard. Some forms also use degrees between joints. And that's also difficult. For instance, a pelvic to thigh angle of 120. That's very interesting, but in order to reproduce that in a seating system, you need to have a geometer. So you need to adjust the seating system, put the geometer at the right spot, and then readjust it until you have the degrees that were established in the range of motion. So it's making it very hard, and it makes it also prone for failures and not meeting your outcomes. And then additionally, it's not specific enough for building a seating system. The quantity, the distance measurements, failing to quantify fixed, moderate, flexible, severe, fixed, severe, flexible. It's also, there's in the most developed forms that I could find, there is also not a way to say how much a partway flexible to neutral range of motion deficit of the spine, how much that is. So that makes it really difficult. And then additionally with COVID, you probably have the same where you are. In Europe, we have a shortage of physical therapists, OTs, staff. So it's very time, and also technicians, skilled rehab suppliers. So it's time consuming, and it doesn't lead to good outcomes and potentially poor efficiency. So so I'm going to propose a couple of techniques. By no means I'm implementing it or saying you have to do it. It's a proposal. I have no commercial interest. I'm a clinician. I'm just trying to make your process perhaps easier, quicker, safer, and more reliable and more efficient. But it's still it's a technique. So I'm very humble. And the validation process will also get a survey to see if you agree with that or not. So it's a work in process, but it worked well in our clinic, and that's why I thought it was good. And for that, I said, well, we're going to create a form that's going to check face validity, is to check basically the extent of this new technique, if it works better to solve our challenges than what we currently have. And the content, is it relevant to actually measure what we're trying to do, the supra-pelvic scoliosis? And then the aim is then to collect data from you, seating professionals. It can also be prescribers, OTs, physios, seating specialists, MDs. But it probably would be nice to have experience in the field, 5 years. If it's less, it doesn't matter. But in case, the importance is that you have some experience in working with that data and the assessment process, so you can compare different techniques. So here we go. I will be very quick, and I will also show you how you can use it, for instance, with a freeform seating system, a head support intervention in the process. So I would still start, so I use my wife in our clinic. She's also a physiotherapist. So we did this in our clinic. We have a staff of 5 people. So I did this just to document it and make it very visible, or as visible as possible. The observation is simple. You look at the alignment of the pelvis and the shoulders. You can put your fingers on the aces left and right to see if sorry, Siri kicks in for some reason. So you can see if the height is at the same level. You can also determine if there's a shift forwards in case of a rotational deficit. And then you do the mat assessment in supine. So the transfer in supine is done. And then I'm very simple, so I try to keep it as simple as possible, because it's already complicated enough our lives. I hope you agree with that. At least it is in my life. So the simpler it gets, the better. So I said, well, I use sometimes, like dermographic markers, so with children, I sometimes do this technique together with the family. So we explore options with the family. So I make this a very easy and fun process. So basically, you put a marker, and it can even be like a little sticker on the acromion left and right, and on the aces left and right. And then in an unweighted state, you see the direction of those bony landmarks. And then what you need to do now is to figure out how much is this spine flexible, partly flexible to neutral, or fixed. And then the simplest way to do this is to place your knee against the trochanter, and that's basically blocking your pelvis. So it's not moving because your knee is blocking, pushing against it. And then you have the scoliosis, and the scoliosis is kind of like this, convex on this side. So the most convex part will be in the middle, and then high on the concave side would be under the armpit, right? And I'm placing one hand there and one hand there, and then I keep the knee at the same spot, and then I'm trying to give a corrective force. Of course, with a fixed deformity, you don't need to do this because it will be fixed, because in this case, there's a surgery, so it will be fixed. So this is mainly if you have to determine if it's a partly flexible or a flexible or a fixed deformity. And then you stop, you do a gentle force. I use my whole hands, my whole forearm. And then when the range of motion stops, I'm giving a force, but I don't see any corrective movement. When the client has the slightest pain, I stop. Or when I see or feel that there is an increased pressure at my knee, then I stop, because then there is a compensation by trying to get the pelvis out of the correction. So then there is an escape from the corrective force. So that's also an indication to stop. And I basically keep, and I stop there. And from that point, so that's the procedures explained step by step. So I'm the hands on the concave side, the hands on the convex side. And then you stop where the range of motion ends. And of course, with this client, yeah, you don't need to do this, but you have several options. Remember, if this is, you have option 1, you have option 2, and you have option 3, right? And it helps to already know what option you want to choose with that client, because if you don't know what option, you're going to be fitting a long time. It's going to be complex. Your life is going to be, the client will be annoyed because it's painful. You're not meeting the goals. But basically, what the different option 1 is, basically, you have an asymmetry, severe asymmetry of the pelvis, and you have an asymmetry of the shoulders. And option 2 is basically you're getting more symmetry of the shoulders, but you have more asymmetry of the pelvis, right? Because the spine is fixed. Or you can have option 3, which is kind of a little bit in between. So you have an asymmetry of the shoulders and you have an asymmetry of the pelvis. So you can choose that. And what I did is, on the therapy table, I put like a transfer sheet, and I basically exploring all these options by basically transferring the client in supine, and I keep the goal in mind. And the goal was to have improved function of the right arm, because that's the arm the client is using to control the head support. But you can also use that. You can also use, for instance, the client complains about it's difficult to maintain my head position. Then you can also figure out what the best position would be to have more function here and more function with the head. And in general, that tends to be the position with most of the symmetry of the shoulder. Because if the shoulders are more symmetrical, then it becomes easier to control your, if for instance, you control your upper extremities. If your shoulder on the right side is rotated high towards the opposite side, it becomes more difficult in general for the client to use the upper extremities. So here I'm tend to go a little bit towards symmetry on the shoulders. So I'm positioning, aligning the client in that position, and then I basically see that my scoliosis is, my pelvic obliquity is worse. I'm not worried too much about that, because my main goal is upper extremity function. But that's a little bit how I do it. So you can explore your options doing that, partly fixed, partly fixed deformity, preference on the shoulder symmetry. You can determine what works best in order to achieve your goal. And then I'm basically using an angle, a 90-degree angle, and that can be a book, so you don't have to invest money in it. And I locate the ACEs, and I put a little marker right on the therapy table. And so there's sticky dots here, right? And I put that right on the therapy table. And I also do that and also do that on the ischial. So I'm compressing the tissue at the ischial tuberosities, and I put the angle there, and then where the angle is making contact on the therapy table, I put a sticky dot, right? So that determines the height difference between the ischial tuberosities left and right. I'm also doing the same for the convex and the concave side of the scoliosis. So I'm also clearing the axillary nerve. So I'm staying a safety distance of at least 2 fingers away from it. And I'm making a marker on the table. And then you have all these data spots on the table, right? All these dots here after you've done the assessment. And then you can take your time, you have done all the work, and now you have a lot of things. So I put a marker here, and I put a marker there. And that's the widest point of the pelvis, right? So I did that with the angle here, something like this. And that was at the widest point of the pelvis. So, and that's going to help me to measure with my tape measure afterwards. And that's basically my seat width. And I have it clear, 100% correct. And then I also have palpated the ischial tuberosities, left and right. And now I'm measuring the height difference between the left and right ITs. And I have a distance measure that I can reproduce or ask the rehab technician what would be, for instance, the best solution to accommodate that height difference, right? And then I can, now I have, fantastic, I have a whole set of data points. Now, if I'm taking the distance between the left IT and the height of the concave side of the support, then I have the height of the lateral trunk support on the concave side. How cool is that? You have a distance measure. And now you do this on the opposite side, and then you have the height of the lateral trunk support on the convex side, right? So that distance between the right IT and this marker where you thought was best for supporting the thoracic spine, then you have that data point as well. So you have exactly that distance measure. And then you can also do this. You can also measure the amount of offset on the concave and the convex side of the lateral trunk support you need. And that's brilliant, because this is your widest point of the pelvis that will be corresponding to the width of your wheelchair. And you make a line aligned with the table here. And then this distance here will be the amount of offset I need on the lateral trunk support on the concave side. And now I do the same on the opposite side, the width of the chair, and then the width measurements, and then the amount of support or offset on the concave side would be the distance between that line. And then you have a full-blown system. You can start building, and that's beautiful. So how can you build now? Well, I used the example of a freeform back support and seating system from Sam. And it's a beautiful system, and it's a whole sheet of material, and I'm using that data already to basically to prepare the system for the exact width of the client. So in my case, I have width and depth measurements from the assessment, and I'm already making that ready. So I'm basically have 2 sheets here. This would be for the lower extremities, right? And then this is what I basically need. I also put sticky dots on it, so I know exactly what I need in terms of material to accommodate that. And I do the same. Oops, I'm going back here. Sorry about this. Hopefully that still works. Yeah, it does. And this is for the trunk support. And I'm basically marking off the material that I need, and then I basically eliminate. So basically the units, the pots here, they can be customized. You can take them away, or you can add materials, and then you can actually build your seating system. And I'm building it according to the measurements that I've been provided by the assessment. And then, yeah, correct me if I'm wrong here, because Sam has done a lot of fittings as well with the freeform seating systems, back and seating systems. So feel free to add in. Yeah. And then, so basically this would be your seat, and this would be your thoracic or your trunk support. And then I'm releasing those elements so you can fold it, right? And then you have kind of the shape that you need according to the data that you've been provided from the assessment, and then you see already a pre-shape of the client's spine.
Mhm.
And then you know, these pods here are connected with a screw, a central screw, and that's basically holding the other elements together. And they're not fully tight yet, but they are stiff, so you can shape it with your hands around the client.
Yeah, from the
And what-
factory,
Yeah.
we torque the sheet to a specific level so that it is moldable, but it's not loose, so that it you can shape it by hand without it being floppy, basically.
Yeah, it makes it really easy. So, and then I basically have the client, you know, so the client would be on a supine position, and you can see I use packaging material, but the reason why is that it's a fitting of the form, and I want to make sure that it's easy done, and it's simulating about the thickness of a material that you would put in between afterwards, like for instance the foam options that you have, or you can even have different materials like stimuli options. But I'm using that for the fitting. And now I'm aligning the client in the position that I thought was best for function or for the client goals. And I'm doing then 2 steps. I'm starting with the lower extremities, and I'm using a chair to hold, or you can also have a colleague, but you know, usually I do things all by myself. And here we have, for instance, a left and right hip extension deficit. And I'm basically putting the client in the end of the range of motion. And then I start fitting the shape around the lower extremities. And I start from the ITs, and then I work my way forwards. That works well for me. Why is that? Because if your ITs are supported, then it becomes easier to work your way towards the end of the material. But I guess that's a bit of a preference thing. But then I know that the key points pelvic and the pelvic height difference is taking into account, right? So I have done that on the left side, I've done that on the right side, and you can see you can shape perfectly around it. And that's also nice because you can have even a small abductor, a medial distal thigh support, correct terminology here, to make sure that the hips are being supported in the position that you that corresponds with the range of motion of the client. So, and then you have done, so I have basically fitted for an asymmetric pelvic position. If this would be a fixed deformity, then I would have more support or more symmetry of the shoulders. So then I basically have done the lower extremities and the pelvis in the right spots. And then I start concentrating on fitting the PSIS region, posterior superior iliac spine region, to support the correct pelvic to thigh angle, right? And that's coming in a second stage. So that's basically your range of motion assessment and your infrapelvic assessment. But I'm also using an elastic band here to make sure that the material is beautifully contouring. And then I focus on the zones above it, and I give the support right where we measured it to be correct for the client. So this will be concave and convex, thoracic, left and right. And then, so that's a relatively short process that takes 30 minutes roughly. When you have help, it makes it easier, but you have then the shape. And then I'm tightening all the elements again. So we have then a close to final shape before we, of course, going to fit it. And then that shape is kind of done. And then you can add some reinforcements. You know, you can add elements that you can to rigidify it. For instance, here the lower extremities have a strong concave shape for the medial distal thigh support. And then I'm basically putting an element there to support the correct posture of the client and to correct alignment of the client. So you can easily mount that with a screw on the freeform elements. And then I prepare the wheelchair. I'm stripping the seat frame and the back frame, and then I put the mounting brackets on the wheelchair. Right, here you go. I'm also using a mounting bracket for the seat base, left and right, and then I start fitting the system on the wheelchair. Here you go. And then I'm a very simple guy, so I used the paper that you use to protect your therapy table, and I'm cutting that to the right size. So you kind of I basically cut a template from paper, and then you can start cutting the foam, or there's other options like pressure redistribution materials, like Stimulite material that you can use. And then you can actually start building it and cutting the foam, and then you can put a cover on top of it. Yeah. So it's also important to maintain your microclimate. I'm not going to go in detail, but there's a lot of research on microclimate. We know that moisture will overhydrate your stratiocorneocytes. And that's, if you're looking at the outer structures of your skin, you see that the stratiocorneocyte cells are these brick-shaped cells, and they are connected with an enzyme. And if you take a bath and you spend like a long time in bath, you see that your skin gets wrinkly, and that's because your bonding enzyme between those stratiocorneocytes is overhydrated and stretched. And then you have more friction, so there's more friction when you are moving. And additionally, we see that it can cause lesions because that bonding between those stratiocorneocyte cells is basically weaker. So you see that your skin or the client's skin becomes more vulnerable. So just a little note on microclimate. You transfer the client in there, you do the fitting process, you do some fine tuning. You can also make that fitting process longer. And then I usually do a pressure mapping just to make sure that I have a nice consistent shape. That's optional. You don't need to do it, but you see that there is no peaks of any fitting that I've done. It seems like a good distribution of the seat. This is the back support system. So you can see that this is all lateral part. So this will be the back support. That would be the right of the client, and that would be the left of the client, and that would be the bottom part of the back support. And you see that the main support comes from the lateral elements, and that's basically the contouring of the system on the convex and on the concave side. And this is then the seat base, and that's the front of the seat, and that's the back of the seat, and that's your right of the seat, and that's your that's the right of the seat, and that's the left of the seat. And this region would be the IT region, and we build an asymmetry to simulate a scoliosis with a fixed component. So we chose for asymmetry of the pelvis and symmetry of the shoulders. So it's logical that you have an asymmetric loading pattern of your pelvis, but it seems like a good redistribution of forces, and I don't see high peak pressures. So it's still a zone to watch out for, but it gives me a bit of reassurance. And then you can add some other elements. You can add, for instance, a bracket system directly on the freeform elements in this case, and then you have a head support that you can fit. So that's optional, but it can be done. And you can also have flexible postural support devices like hip and thoracic supports, commonly used as belts, but flexible postural supports is better. And you can mount them directly on those elements as well. So that's perfectly and easily done, thoracic and pelvic. And then you should think you have done a good job, but be careful. It's still not done. Even with this technique, you still need simulation and see if that solution is provided and fits for the client. A fitting process is still very important because your client always has the last word. He will need to see if it's agreeable, if it meets his goals. So the simulation is still be done. There's also a limitation to my technique. The technique that I use to assess supra-pelvic scoliosis is maximum range of motion of the client, and it's not taking the effect of over time, the effect of postural aggravation by gravity into account. So what it means is that you still have correct measurements on width. You still have height, IT, correct. Those measurements will not change with gravity or with time, but the amount of offset of the laterals in case of a fixed or a partly flexible to neutral deformity might need to change to accommodate for the effect of gravity. So an adjustment over time of any lateral trunk supports on a convex and a concave side still needs to be considered. So it's also important that you explain to the client. So the offset is then the main variable that needs to be taken into account. And the technique that I showed you is also not working for high tone clients. So a severe dystonic client where it will be difficult to maintain an alignment until you take notes, then it will be nearly impossible. And bariatric clients as well. For the dystonic population, there is a different assessment technique that I developed. So that's part 6, if you remember. For the bariatric population, it's really difficult for obvious reasons. But I don't really know a very good assessment or a consistent or a validated assessment technique yet. So perhaps hope not. But if there is another COVID, I will put my mind to that. Right. So I just want to end it there from my end, and I also want to invite you to participate on this survey on face and content validation. This QR code or the link below will guide you through the survey. We already have a lot of data received from rehab clinics all over Europe, some in the United States and Canada, but it would be really good to have your feedback. The survey also guides you through the process. It will take you about 30 minutes max to provide feedback, and it will also be a refresher on the technique for supra-pelvic scoliosis, as it will give you another overview. But here is the link, and there is the survey as well, and I hope you can participate. And I want to thank you for listening to me. Thank you.
Thanks very much, Bart. And feel free to reach out to us. We've got lots of resources on our website, symmetricdesigns.com. There's some tips and tricks about freeform, some alternative fitting techniques, some videos, and just a lot of information that hopefully will make your seating assessments easier. So thanks very much.
Thank you.
Thank you, guys. I had a couple of questions that came to mind. We have a few minutes left, and I was just thinking, this is amazing technology. I wondered if you could describe, like, once you set up that system, what kind of typical maintenance do you perform? Do you need to check and make sure all the connectors are tight, or is it I'm sure there's some thing you need to pay attention to?
Yeah, so for technical maintenance, there really isn't a lot to do. So the clamps for freeform are made of 6061 aluminum, and then the connectors are a composite material consisting of nylon, rubber, and glass. And so the rubber dampens vibration, which prevents things from loosening up. The screw in the center of the clamp is actually, it's a black zinc coated stainless steel screw. So you have that stainless steel screw going into aluminum. So the two different alloys, when you tighten it up, they actually bind together. So we've had clients using the same freeform system for over 7 years now. And, during our initial launch of freeform, our initial clinical trials with it, as long as you tighten the system up as firm as you can during that initial fitting, it won't loosen up over time. clinical maintenance, obviously if there's changes in posture, you want to address that, you can go back and make those changes. But technical maintenance, you can certainly inspect the system. Occasionally you will find some of the links break, and that is indication of a high stress area. And to address that, we have the solid alloy two-ball connectors, which we recommend you replace the black two-ball connectors with in those high stress areas.
So, and Bart mentioned that it's not really good for bariatric clients. Is there a specific weight limit on this product, or?
So the fitting assessment that Bart presented is it's not really applicable to bariatric clients. However,
right, yeah. So sorry to interrupt here, Sam. Yeah, my seating technique, so the supra-pelvic assessment technique, is not suitable for bariatric clients. That's basically a statement, or severe dystonic clients. So that's the data collection phase, so the mat assessment. So it's not, I didn't mean it to give you indications of your product. So Sam, I just want to clarify that.
Yeah, no, thanks, Bart. So to address your question, no, there is no weight limit for freeform seating. And the reason for that is you can add as much reinforcement as needed. So we actually have backrest kits that go up to 24 inches wide. And within those kits, we supply additional alloy two-ball connectors, additional mounting points, so you can really reinforce the system as much as needed for that client.
Okay, that's awesome. I have one last question. The idea that you can add or take away from it, right, as you need to in the future. So, with all the capabilities that it offers, is there a life expectancy? Do you need to replace it every 5 years, or?
Yeah, so the clamps, the hardware itself, it's all alloy. There's nothing on it that will rust. It's either aluminum or stainless steel. So those components typically do not wear out. The black connectors, the two-ball connectors and the edge balls, those are very durable as well. They actually have UV protection built in and salt corrosion protection. So they last quite a long time. We do recommend you inspect the cover. Depending on the foam and the fabrics, they can last from 2 years to 5 years, depending on the client and the situation. But the hardware itself is, we've got clients that are still using their same system from 8-9 years ago. So.
Okay. Well, listen, if anyone has more questions, and you can go to the website or send. Do you have your email address or?
Yeah, you can contact myself directly. It's Sam at symmetric-designs.com. And then Bart is also available for clinical input and expertise as well.
Right. I'm trying to write down. It's info. And
very good.
At super and then seating.com. Yeah, it's difficult here.
Yeah, superseating.com. Okay.
Right. And then hyphen between and then seating.com. Right. So you got it. Yeah.
Okay.
Thank you.
And I hope everyone will take advantage of that survey to give more information, because we know the better outcomes come from collection of a lot of data, right? For that purpose. So I want to thank both of you. It's fascinating product, and we will sign off now. Thank you, and we appreciate it.
Yeah, thank you.
Thank you very much. Thank you.
Thanks very much.